SpaceX, Starship, explosion. These three words would soon become synonymous with a major turning point in space exploration history. These words sent shockwaves through the world in November 2023. The news spread like wildfire, capturing the attention of millions who had been eagerly following SpaceX's ambitious journey. Elon Musk's ambitious rocket was supposed to revolutionize space travel. It was designed to be a game-changer, a vessel that would take humanity to new frontiers, making interplanetary travel a reality. Instead, it ripped a hole in Earth's atmosphere. The explosion was not just a setback for SpaceX, but a significant environmental concern. This wasn't just any explosion. The magnitude of the blast was unprecedented, sending debris flying and causing widespread alarm. It was a wake-up call. Scientists and engineers around the globe realized that they had underestimated the power of these rockets and their potential impact on our planet. We had underestimated the power of our rockets and their impact on our planet. The incident forced a reevaluation of safety protocols and environmental considerations in space exploration. The Starship was designed to be the biggest and most powerful rocket ever built. It was a marvel of engineering, a testament to human ingenuity and ambition. It promised to take humans to Mars and beyond. The vision was clear, a future where humanity could become a multi-planetary species. But during a test flight, disaster struck. The rocket, which had been the symbol of hope and progress, suddenly became a symbol of caution and the unforeseen dangers of space exploration. The rocket exploded not once, but twice. The first explosion was shocking enough, but the second one was catastrophic. The second explosion was the real problem. It occurred at a much higher altitude, where the atmospheric conditions are more fragile and susceptible to damage. It happened high above Earth, in a delicate layer of our atmosphere called the ionosphere. This layer is crucial for protecting our planet from harmful solar radiation and maintaining communication systems. The damage to the ionosphere raised serious concerns about the long-term effects of such explosions on our environment. Scientists began to study the data meticulously, trying to understand the full extent of the impact. In the aftermath, SpaceX and other space agencies had to rethink their strategies. New safety protocols were introduced, and environmental impact assessments became a critical part of the planning process for future missions. The incident served as a stark reminder of the challenges and responsibilities that come with pushing the boundaries of space exploration. It highlighted the need for collaboration, innovation, and a deep respect for the delicate balance of our planet's environment. Despite the setback, the dream of reaching Mars and beyond remains alive. With lessons learned and new measures in place, humanity continues to strive towards a future where space travel is safe, sustainable, and within our reach. Think of the ionosphere as Earth's sunscreen. It's a layer of our atmosphere filled with electrically charged particles called ions. These ions are super important. They absorb harmful radiation from the sun. This radiation can be dangerous to us and our technology. The ionosphere also plays a vital role in communication. It acts like a giant mirror, reflecting radio waves back to Earth. This allows for long-distance radio transmissions. Without the ionosphere, our world would be a much quieter place. The Starship explosion tore a hole in this protective shield. Scientists were shocked. The event was unprecedented, leaving experts scrambling to understand the full extent of the damage. The explosion was not just a minor incident, it was a catastrophic event that had far-reaching implications for our understanding of atmospheric science. They had never seen anything like it. The scientific community was abuzz with theories and hypotheses, each more alarming than the last. Researchers from around the world began to collaborate, pooling their knowledge and resources to investigate this anomaly. The hole was huge, stretching for thousands of kilometers. It was as if a giant hand had reached down and torn a gaping wound in the sky. The sheer size of the hole was mind-boggling, and it raised questions about the stability of our atmosphere, and it lingered in the sky for almost an hour. This was not a fleeting disturbance, it was a persistent anomaly that defied easy explanation. The sky seemed to ripple and shimmer as if struggling to heal itself from the damage inflicted. This was a big deal. News outlets around the globe picked up the story, and it quickly became a topic of international concern. Governments and space agencies were called to account, and emergency meetings were held to address the potential risks. Ionospheric holes had been observed before, but they were usually caused by natural events like solar flares. These natural events, while disruptive, were part of the Earth's natural processes. However, this man-made hole was a different beast altogether. This was the first time a rocket launch had caused such a significant disturbance. The implications were concerning. If a single launch could create such havoc, what did that mean for the future of space exploration? Could we be inadvertently putting our planet at risk? A hole in the ionosphere could disrupt radio communications, GPS systems, and even power grids. The potential for widespread disruption was enormous. Critical infrastructure that we rely on daily could be compromised, leading to chaos and confusion. It was a stark reminder of the potential consequences of our ventures into space. As we push the boundaries of exploration, we must also consider the unintended side effects. The Starship explosion served as a wake-up call, urging us to tread carefully as we reach for the stars. What surprised scientists the most was the sheer force of the explosion. It wasn't just any ordinary explosion, it was a cosmic event of unprecedented magnitude. The data on their screens told a story of immense power and energy, something they had never encountered before. The reactions of the scientists ranged from disbelief to awe as they tried to comprehend the scale of what had just occurred. The Starship didn't just burn up in the atmosphere. It disintegrated in a manner that defied all expectations. The breakup was so violent that it sent fragments hurtling in all directions, each piece contributing to the chaos. The atmosphere itself seemed to react as if it were being torn apart by the sheer energy of the event. It created a powerful shockwave. This wasn't just a ripple, it was a tsunami of energy that spread outwards, affecting everything in its path. The shockwave moved with such speed and force that it left a trail of disruption in its wake, altering the very fabric of space around it. This shockwave ripped through the ionosphere, tearing apart the delicate balance of ions and electrons. This was new territory. The ionosphere, a region of Earth's upper atmosphere, had never experienced such a violent disturbance. The balance that had been maintained for eons was suddenly thrown into chaos, and scientists were left scrambling to understand the implications. Previous ionospheric disturbances had been caused by chemical reactions. This was different. Those past events were relatively minor, caused by predictable and understandable processes, but this was something else entirely. The sheer brute force of the explosion was unlike anything seen before, and it demanded a new understanding of how such events could impact our planet. This was pure brute force, the kind of raw energy that could reshape landscapes and alter the course of natural phenomena. The explosion's power was a stark reminder of the forces at play in the universe, forces that could dwarf anything humanity had ever witnessed. The energy released by the explosion was enough to physically alter the properties of the ionosphere. It wasn't just a temporary disturbance, it was a fundamental change. The ionosphere's composition and behavior were altered in ways that scientists were only beginning to understand. The long-term effects of this event could be profound, potentially affecting everything from satellite communications to weather patterns. It was like hitting a gong and watching the vibration spread. The initial impact was just the beginning. The energy radiated outwards, creating waves that traveled far and wide. Each wave carried with it the potential to cause further disruptions, and the full extent of the impact was still unfolding. The scientists knew they were witnessing a historic event, one that would be studied and analyzed for years to come. Section 5, fueling the fire, but the surprises didn't end there. Scientists believe that unburned fuel from the Starship may have made the ionospheric hole even worse. This fuel, released at such high altitudes, interacted with the ionosphere in unexpected ways. It's like adding fuel to the fire. The unburned fuel from the rocket kept the ionosphere from healing itself. It was a double whammy. The explosion created the hole, and the fuel made it last longer. Section 6. The future of spaceflight. The Starship explosion was a turning point. It forced us to confront the environmental impact of space travel. For too long, we had focused on the excitement of exploring the cosmos without fully considering the consequences. The message was clear. We needed to be more careful. As we enter a new era of space exploration with more frequent launches and larger rockets, we need to understand how to minimize our impact on the planet we're leaving behind. Section 7. Monitoring our atmosphere. The first step is better monitoring. We need to keep a close eye on the ionosphere and other layers of our atmosphere. This means investing in more satellites and ground-based observatories. We need to be able to detect these ionospheric disturbances early. This will give us time to take steps to mitigate the impact on our communication systems and other technologies. It's like having a smoke detector for the ionosphere. Section 8, predicting the unpredictable. But monitoring is not enough. We also need to get better at predicting the impact of rocket launches. This means developing sophisticated computer models that can simulate the complex interactions between rocket exhaust and the atmosphere. It's a daunting task, but it's essential. Imagine being able to predict the size and duration of an ionospheric hole before a rocket even launches. This would allow us to plan accordingly, minimizing disruptions and ensuring the safety of our critical infrastructure. Section 9. The bigger picture. The Starship explosion was a reminder that we are all part of a delicate cosmic ballet. Our actions have consequences, even when we reach for the stars. It's time to move beyond the romanticism of space exploration and embrace a more responsible approach. An approach that balances our thirst for knowledge with our responsibility to protect our planet. Section 10. Space exploration, a balancing act. This doesn't mean we should stop exploring space. Space exploration is in our DNA. It's who we are as a species: explorers, dreamers, pioneers. But we need to explore responsibly. We need to find ways to minimize our impact on the environment, both here on Earth and in space. We need to be mindful of the delicate balance of our planet and the universe beyond. Section 11. A new era of space exploration. The Starship explosion was a wake-up call, but it was also an opportunity to hit the reset button, to rethink our approach to space exploration. Let's learn from our mistakes. Let's use our knowledge and technology to explore the cosmos in a way that benefits humanity and protects our planet. Let's usher in a new era of space exploration, an era marked by responsibility, sustainability, and a deep respect for the universe we inhabit.